here with Brian Matheson, the technical account manager at Maya Data. And we're going to do something very special today, aren't we, Brian? It's going to
Yeah,
be a new kind of thing for the DoK community, but I really appreciate you coming here and bringing me this idea. It's such an awesome way to learn, right? So, today, what we're going to do is part one of creating a little Flask API, right? And I
right.
would love, can you give us a bit more details on what the hell we're doing here?
Sure, yeah. Yeah, so in order to sort of exercise Kubernetes, I figured it would be instructive to write a little API, something that we can query over the net with curl, something that'll return simple responses, and something that we can connect to a database later on. Now, once we have it running against the database, I figure we can kick the tires on it a little bit and do some some high performance exercising in the application, as well as put together some test code. But first things first, we're going to take a look at just the most basic Flask API. Now, Flask is a library for Python that allows you to construct an API really easily. And so what we're going to do is walk through how you would write an API in Flask really simply. Um, and then uh, and then we'll go over how to get it running inside of a public network presence using Kubernetes.
So
Sound good?
yeah, that's an awesome way of putting it. I mean, I think the general design here for today is looking at what we're going to be doing. We're also going into setting up the app, and then we're going to be using a database. We decided on using Postgres, right?
Well, I think we might use MySQL, but the
Okay,
beauty of
MySQL, sweet.
Kubernetes is it makes it easy to snap in one database or another. Um, and uh, and so we could, if we wanted to, try both
There
later
we
on.
go. Getting
Yeah, we could
interesting.
even
I like
switch
it.
it from MySQL to Postgres. We'd have to change the query syntax in a few places, but
Mhm.
easy enough to do.
Yeah.
So with that,
Yeah,
you
go ahead and
mentioned,
share your screen maybe, and let's
yeah,
get
yeah.
into it.
Why don't I share it out and let's take a look at a couple of slides when we do that.
Cool.
That I think will be instructive. And let me
Cool,
find.
because there was another couple things that we had mentioned that we might wanna do, which is, once we have this little API and it's connected to the database, whatever database we choose, we also were thinking about creating some kind of front end, right? And then also maybe we want to bring Redis into the picture. And who knows, maybe later on we could do some chaos engineering with Litmus. And so I think there's a lot of ways that we can go with this mini series that we're doing right now. But for the first part, it's just getting the basics. Let's get the skeleton down.
Yeah, yeah, exactly. And we'll get a little sacrificial API that we can throw around and we can extend to suit our needs. I mean, putting a caching layer in there would be great.
Mm.
Um, Exercising it with Litmus to make sure that the API still connects to the database after it gets interrupted. These are all things that we'll definitely take a look at later on. Um, but first, let's just take a look at what we're going to put together.
Perfect.
Um,
So this is
uh,
all available on GitHub, just so
yeah,
everyone knows.
this is available on GitHub. We'll go back to this slide and it's just right now it's just under my personal account. It may move in the future, but you should be able to find it there anyway.
We'll probably, by the time the people look at this video, we'll put it in a link in the description, and we may move it over to the DoK repo too, so people can play with it.
Yeah, sounds great. And what we're going to do is we're going to run this Python Flask application. Now, Flask runs underneath of Python, and when we deploy it in production, we're going to use this G unicorn. But for right now, we actually don't have G unicorn in place in this example. Um, you can see that I have the server running in this window here, and that if I curl to localhost, since I'm running it on my local workstation, I get a message back. I get this ACK, and then I get my prompt. So let's take a look at how we got to this point. So if I switch back to my terminal window here, we'll take a peek at this API and see how it's structured. There we go. So inside this API directory, we have a few files at the top level. The first thing you see is an app directory, and if we look inside the app directory, you can see that there's an application.py file and a blueprint.py file. And the blueprint is where the meat of the application is. And there's also this init file. And we'll take a look at all of these in order. But I want to highlight what's in the blueprint right now, because this is really the business end of the application. This is what we want to do. Nice. We want to hit this round at slash, and we want to return this string. And so Flask makes it really simple to do that. And you can add on a lot more code to do a lot more specific things. If you need to look at the request headers or do authentication, Flask provides mechanisms for all that. But one of the beautiful things about it is that simple things are really simple to do with Flask. So let's take a look at some of the rest of the structure of this. It all starts with this init.py, and that actually creates the Flask application and registers the blueprints with the application so that the app knows where to find which functions associated with the routes that you're hitting when you're using curl. So if we take a look at app.py, that's exactly the same thing as init.py. So this is extraneous, and I think that I need to just simply remove that. But I'm going to test this out first and make sure it runs. And in order to do that, we have this little script that we put together, run py, that just says, if I'm running as main, then we create the app and we run it on localhost. Let's go ahead and run that now. So you can see that it's serving the Flask app, and then it's in a development mode. And in development mode, it's really convenient to edit the file, and edits get sort of incorporated into the application immediately, which is a convenience. But for testing purposes and for exercising the application, this is exactly what we want. So if we go to curl, and we curl at localhost 8080, because you can see we're listening on all addresses, port 8080. We got our ACK back, and we got a little log message because we're in debug mode that says, hey, we hit this URL, we got a 200 response, and that's how we know everything's working from either side. So we have this simple application. Do you have any questions about how the app goes together in general?
No, I think this has been pretty clear.
So if we wanted to make a simple modification, we can say pong and run our server again, and now we get pong back. Great. Okay. So the next step is really to get this thing into a container. And in order to do that, we have this Docker file that we put together. And you can see from this Docker file that it's really simple. It just starts from an existing Python distribution, copies the application that we built into place, and applies the requirements.txt file to import all the dependent libraries that that Python needs in order to get this app up and running. let's take a look at that requirements file, if I can find it. So you can see that we have a pretty simple list. We've got Flask, we've got gUnicorn, and we've got gEvent, which is something that gUnicorn is dependent on. Now, again, this could get more complicated if we wanted to specify versions that we needed to use, or if we wanted to specify additional packages that we want to include to to give our API more functionality. This is where you include that, and simply modifying this file will build out the Docker image with all the dependent libraries. So going back to the Docker file, you see there's this entry point at run.sh. So let's have a look at run.sh. And you can see that is just a run of the gUnicorn application, which will load the Flask app and run the Flask app with 4 workers in the gEvent worker class. And it'll listen on all available interfaces on port 8080. It's really that simple. So if we run this run.sh, I think I might have to apply the requirements. Let me just do pip3 install API requirements. I think it's -r. And now we can say app run. Oop. All right, it blew up. That's great news.
Now let's figure out why.
Yeah. So let's take a look at the error messages that we're getting back from gUnicorn. So it fired up. It's listening on all those ports, or on all those addresses on this particular port. So we're not root, but we're allowed to listen on this port. So that should be good. All right. And then we get this trace back in spawn worker when we're importing the app. And it says no module named app. So let's take a look at that. Now, if we go into API and run.sh, app create app is the call that we're entering when we run gUnicorn. So if we just do run.sh again, interestingly, it works. So you see that it's location dependent because it's looking for the libraries that it's importing. And there's a specific path that it's going to look in when it goes to import those libraries. When we ran it from that directory up one, it didn't actually go find the right libraries. But now we're running, and we should have, a bunch of little workers running in our local system, and we should be able to curl localhost to get Pong, and we should be able to say, well, true do done. Look at all those Pongs.
Nice.
So it's running. There's a bunch of instances of it, and now, of course, it's running on my workstation, so nobody else can access it. So that's the whole idea of containerizing it in the first place and getting it into Kubernetes.
So that would be like step 1. We've been able to initiate that.
Yeah, we've got our little API. We've got a program that we're going to containerize. We've taken a look at this Docker file, and now let's build it. Great. So you can see that it just goes and steps through each of the elements of the Docker file and builds up the image. And then we go ahead and tag it. Let me see if I have Docker tag. And then we want to grab this little string here and simple Flask API. And yeah, looks good. And then Docker push. All right, think. I used a different name for it, so we'll have to change the deployment manifest, but that's okay. So let's see, what have we changed so far? All right, we changed the blueprint from act to Pong, and that's fine. And now, now that we have this running in Docker, or built as a Docker image, let's go ahead and take a look at the deployment materials we're going to use to get it into Kubernetes. So this is actually a manifest that includes a service definition as well as a deployment definition. Now, you can see with the service definition, it's selecting an app called API. It's exposing port 8080 on that container via TCP, and it's going to put it on a load balancer, which it'll be convenient for us to be able to access it. When you're running an API like this on the public internet, you want to be aware that when you put it on a load balancer, anybody can access it. And so you can use a lot of different mechanisms to protect this. But one of the things that we might want to do is run it in cluster first to test it. I think that's a little bit out of scope for this, and there's really not a lot of security concerns with this API because it's literally just returning a fixed string.
But it's a good best practice to keep in mind.
But as a best practice, you would take an API like this and put some authentication layer around it and make sure that it was only accessible via an HTTPS connection, typically. And then once all that's in place, that's when you would put it on the load balancer. And Kubernetes makes it really easy to do that pre-work ahead of time and get everything secured before you expose it. So it's a feature. So we talked through the service a little bit, and then the deployment, you can see that it has the same selector, and that it has one replica. We're only going to run one instance of this API, and that's different from the -W4 that we used in gUnicorn, which specifies that it's going to run 4 workers inside each container. So we're sort of layering these sort of layering up the application. If we wanted to scale it up to a number of replicas, we can scale it up by chunks of 4 workers. So let's see, what else do we have? We have the spec for the container. Very simple. We have the image, which we know we changed it to a different name. So then I also have these comments in here in case we want to run the debug version. We can just uncomment this and it'll use a different command than the entry point command specified in the Docker file. And then we have this port defined so that we can get to our service. So let's modify this real quick. Well, before we do that, let's take a look at the cluster. So kube control is the way that you talk to your Kubernetes cluster typically. And we're going to get the list of nodes so we make sure we're running all these commands against the correct cluster. So this is this is a test cluster that I have. It's based on kops and it's running in Amazon, AWS. So if we get the list of pods, Well, let's take a look at the namespaces. So we have a default namespace. We have this namespace called foo, and we have a few other namespaces that are common to Kubernetes deployments, and we also have PGO namespace for deploying Postgres easily. But the namespace we're going to look at right now is the foo namespace. So we're going to take a look at the pods in foo, and we're actually going to take a look at the services in foo too. So you can see that this is actually up and running right now. I have an earlier version of this running, and so we should be able to curl this guy and get a response back, and it won't be Pong, will it? No, it's ACK. So we know this isn't running the latest version. Oh, well, we're not running our server, but because if it was running the latest version, we would have gotten a Pong back. We just built the container with the latest version, and we pushed it up. So why don't we take this down? I'm going to scale this down. And foo API replica 0. And now that pod is terminating. Still terminating. Well, I guess that's going to take a little time.
Did you mention, sorry if I missed it, where you're running this Kubernetes cluster?
Yeah, it's running in AWS, and I use kops to build it. But there's a million ways to build a Kubernetes cluster right now, and there's no particular reason that I'm using kops other than, simplicity and it's just very easy to get a system deployed in AWS using it. I like it a lot more than the other mechanisms that AWS provides. But you can see that our pod terminated.
Nice.
Yeah, and if we do, well, we'll leave the service intact. We're not going to make any changes to the service. And as it happens, it takes a while for Amazon's DNS to converge. So in the interest of time, I think I'll just leave that service up. Let's take a look at that deployment manifest. We want to modify it so that it is called simple Flask API. And why not run the development version before running the production version? And then we're going to put it in the foo namespace. Just one more time, get all foo. There we go. Yes, we wanted to delete the deployment too. We did scale it down, but we didn't delete the deployment. So let's kube control, delete, deploy, foo API. There we go. Now we're just left with the service. We can apply this deployment manifest. The service API is unchanged. It creates a new deployment. And that deployment is coming up now. Looks like it's running. And yeah, let's go for broke.
Yeah, the moment of truth.
Pong. So it's running the newer version of the container now, and it's running it on the public internet. So if we left this up and running, anybody else could get a Pong if they wanted to. Now, I think in the next session we're gonna go build on this stuff, and we'll take a look at how to connect the database in. and how to stitch the Flask app to the database, and focus on the logic that we want to lay into this little API. Sound
Yeah,
good?
this has been awesome, man. It's simple, it's easy, quick to do, but also has a lot of information there.
Yeah. I hope it's been helpful, and we'll do another one again soon.
Right on. I appreciate your time, Brian. And thanks
All right.
everyone for watching. We'll see you soon for part 2.